my name is Anisha binti Masukri, and in this video, I will explain about my STEM teaching tools, which the topic is EPSP versus IPSP. The transmission involves release of chemical messenger known as neurotransmitter. Neurotransmitter carry information from the presynaptic sending neuron to the postsynaptic receiving cell. As you remember, in neuron structure and function, synapses are usually formed between nerve terminal, axon terminal on the sending neuron, and the cell body or dendrites of the receiving neuron. EPSP stands for excitatory postsynaptic potential, which refers to an electric charge in the postsynaptic membrane which makes the postsynaptic membrane to generate action potential. EPSP is caused by the binding of excitatory neurotransmitter. So the most common excitatory neurotransmitter is glutamate. The presynaptic membrane will release the glutamate, and this glutamate will bind to the receptor on the postsynaptic membrane. The binding of the glutamate on the postsynaptic membrane will lead to the opening of ligand-gated ion channel. The opening of the ligand-gated ion channel will lead to the influx of positively charged sodium ion into the postsynaptic cell and cause the depolarization of the postsynaptic membrane, which will generate an action potential in this nerve. So the EPSP can gradually adding up until it reaches the action potential threshold. The EPSP can generate action potential because it broke the resting membrane potential nearly to the action potential threshold, therefore caused the firing of action potential to very likely to happen. IPSP stands for inhibitory postsynaptic potential, that refers to an electric charge on the postsynaptic membrane, which makes the postsynaptic membrane less likely to generate an action potential. The inhibitory neuron will secrete inhibitory neurotransmitter to the postsynaptic membrane. So the most common inhibitory neurotransmitter is known as GABA. The presynaptic membrane will release GABA, and the GABA will bind to the membrane on the postsynaptic neuron. So the binding of GABA will lead to the opening of ligand-gated chloride ion channel. The opening of the ligand-gated chloride ion channel will lead to the influx of the chloride ion into the postsynaptic membrane and cause hyperpolarization of the postsynaptic membrane. The hyperpolarization of the postsynaptic membrane is less likely to generate an action potential since it is far away from the action potential threshold.